How was your week, sir?
I'm good, Prisha. Thank you very much. And it's been, I think, 2 weeks since now we have
Yes,
met.
sir.
Yeah,
Yeah.
that's
That's
like last week I had to go to IIT Palakkad for a project
Oh.
inspection. So I was there at IIT Palakkad. So I could not meet you guys in the last two classes.
Oh, that's nice. That's nice.
I've been to this IITs nearby. Any IITs?
What, sir?
Have you been to any IITs? Have you visited any IITs
No,
or NIITs?
I've never visited one.
I visited IIT Madras, so big.
You visited IIT Madras.
Yes, sir.
Who's that? Bharat.
Bharat, yeah.
Very good, very good. How was
I've
that
heard.
IIT Madras? Like, how do you feel?
So it's like a city, but then
Ah.
inside you go inside the campus, it's a forest.
Very good, very good, very good, very
So
good.
big.
See, all IITs are like an ocean. Basically, the IIT is got like I would say that it's basically a kind of
Can you
township.
stop showing my face, Prisha, please? It's embarrassing.
Okay, so but like IITs, if you look at IITs, like IIT is like a township. It has got a post office, it has got a bank, it has got an auto stand, it has got a taxi stand, it has got a kind of cricket stadium. It's got a football stadium.
So what is
Okay.
that? That is the
Sorry.
IIT. It has all those.
Hmm.
Sir, I even went
IITs.
to Bits Plani, even that.
Very good, very good. See, mostly all IITs are like roughly it's about 2,400 acres of land.
All IITs.
The highest is IIT Kharagpur, which has got around 2,650 acres of land, and they also have an indoor international cricket stadium.
Damn, son.
Where is that? Where is that?
West Bengal.
Oh, great.
Okay, where Sundar Pichai studied.
Oh,
Okay. So see the kind of opportunities, like basically in an institution, like where the student is given a lot of opportunity within a campus. Okay, to do several activities are done in one campus. Okay, so mostly in all the IITs, NITs are almost all night students work. Means
all
like
night.
their major
So basically,
thinking
we
part.
won't get any sleep if we join IIT.
No, it's not like that. Basically, you don't have a specific sleeping time there. It happens like, mostly all the nights there'll be a presentation, there'll be a talk on some inventions, ideas, technologies, there'll be a get together, there'll be a gathering, and nights made
So
into
all night we study, all day we sleep.
almost. There'll be a lot of thinking, strategic activities happening. And they just come and sit and discuss, and there are some special areas for that. Okay, so it's like that because why there what happens like all individuals make up themselves. I mean, there's nobody to tell you do this, you do that, you kind of doing like this, why this is, why not like this, why not like that. No questions will not be there. Like you have been given an option to study differently, right? Shaluk, okay, so what was what we discussed in the last physics class, and what did I say to you that we'll be starting today?
We will be starting density today.
Sorry?
We will be starting density today.
Density.
Trust. Oh, yeah.
Very good, very good. Very good. So density is the last part of what topic?
So gravity.
Thrust, pressure, gravity.
It's the last part, right? So yeah, gravity last part, density. Okay. Okay. So let us understand density today. This is a very interesting chapter, and if you concentrate a little bit, if you give a little concentration towards it, we can understand it very easily. And based on that, we have some numericals also to solve it. Then we'll move on to the next chapter of physics. Okay. So, so what is mean by density? Do you have any idea?
The amount of particles per. I don't know. I don't remember. Sorry.
You don't remember means you have already studied this?
We've only studied the
And
formulas and all. We don't actually study definition. Density is mass upon volume.
Density is what actually? Mass into?
Volume.
Are you sure?
Mass by volume.
Mass by volume, mass into volume. Okay. Okay. A nail and a cork. Okay. So now my question is, see, there are H2O in both the containers, same H2O, and it is equal in both the containers. And one container, I have placed a cork, wooden cork, and it is floating. Okay, it is floating on the water, and a small nail is placed. Okay, and that has gone deep to the water. All right, that has gone deep to the water, and it is lying under the like water, and it is very closer to the bottom part of this container. So why do you think the cork is not sinking?
Low density, high density.
Sorry.
I'm not very sure, sir, but looking at the topic, it has something to do with low density and high density. So the density and the pressure on the surface of the water is higher than that
So can I
compared with the.
answer?
Yeah.
So the question is like now, why the nail is sink? Okay. What happened to why not cork? These are the two questions I have with you. His nail is very small.
Yes, it is.
His nail is very small. Okay. Nail is small. Okay. What about the cork?
It is big.
Cork is big. Cork is big, isn't it? Cork is big, nail is small. So what is happening here?
So difference in surface area pressure.
So
Weight of the cork is more and weight of the nail is also less. Okay, see the cork is little. Yes.
Density of the nail is more than the cork.
Density of the
Density of the
nail is
nail is
more.
more than
the
the
cork.
water inside.
So what is mean by density?
The amount of particles per area.
No, anything else?
So amount of particles in like a specific unit area.
In a square unit area.
Okay. So let's basically understand here the cork is there and here the nail is there. So we understood we are talking about that nail is sinked and cork is on top of the water and it is floating. Okay. I'll come back to this area. Before that, I'll discuss few things with you. Okay. I'm rubbing this. So the few things which I'm going to tell you now is okay, what we are learning now? What we are learning, my dears?
Density.
Density.
So in this chapter, let's understand basically few things. Volume of object, then density of an object, then density of liquid. Okay. So density is nothing but actually let's see density. I want to say in one word. Okay, given volume. Okay, whatever mass. Given volume, whatever mass. So I would say density is nothing but, let us understand the formula here. Density is equal to mass by volume. Okay. Density is mass by volume. And what is the SI unit of mass? Mass SI unit?
kg.
Kg. And volume?
Volume is
Volume SI unit? Meter cube?
meter cube.
So kg by meter cube. Density is nothing but density equal to mass by volume, and the SI unit of mass is kg, and the SI unit of volume is meter cube. Okay. So can I rub this? Can I rub this?
Yes, sir.
Okay. So here now what we're going to see is, okay, basically how much mass, okay, exists in given volume. Okay. What is density? How much mass exists in given volume? You understood what I'm saying? Okay. The density is equal to what? Mass by volume. Mass by volume. Basically, the test of what actually we are going to test how much mass exists in given volume. Okay. Suppose you have, I'm just drawing a small picture here. Now let's see. There are trees here. Okay. There are some trees. Okay. Here are a lot of trees. Okay. Picture 1 A and picture 2. Okay. Tree 1, tree 2, tree 3. Picture B. In which picture density is more?
A.
Why?
The amount of trees are more.
Anything else?
Amount of trees are more in the same size of land. See, same volume.
So here actually what we see,
The number of
is,
plants in the same area has increased.
area is same, both the picture. Okay. Picture A is equal to picture B. Area is same. Okay. But what happens? More trees. More trees and less trees. Anna? Less trees. Isn't it? Yes or no?
Yes, sir.
So the thickness is more here, basically. Am I right? Thickness is more here and thickness is less here. Isn't it? So whenever
Sir,
there
how
is
is the thickness?
the air particles, okay, movement of air particle is less, which means the thickness increases. Basically, the condition, there are no space to occupy air. Okay. There are no space to occupy air. Here you have space to occupy air. These are all spaces available where air will get placed. So whenever air takes place in between any object's particles, okay, density will be less. You got me what I'm saying?
Yes, sir.
Whenever air is not placed in between any materials, okay, suppose a material is made up of XYZ material and that material is made, there are no space between that small particles of that material, okay, whichever that particular box or container or shape, whatever is made, okay, so the automatically density will be more there. You got me what I'm saying? Okay, I'll give you one more example. Now look at this particular area. Hope you would have seen this. Okay, this is H2O, and in the same container, same space, this is glycerin. Okay, so which one will have more density?
So what is glycerin?
What is glycerin? It's a thick liquid which generally
So we
used
know
to.
what.
Sorry.
Okay, yeah, if it is a thick liquid, it's glycerin.
It's a thick liquid which is generally used actually in movie shot and all. People used to put in the ears for getting the, like they wanted to make a crying scene and all those things. They put this liquid on their eyes, and it is chemically, you have to learn it later. So this liquid is basically is a thick liquid. Okay, so glycerin is thick, and because of it, density is more. You got me? Glycerin is thick. Okay, so because of it, what happens? Because of what happened?
Density is
The
more in
glycerin
water.
is more. Glycerin thickness is more, and
So
because
it
of that,
settles
density is
down.
more. Sorry.
Nothing, sir. Nothing, sir.
Okay, now I'll tell you one experiment. Suppose we have a rubber ball, okay? This rubber ball we have just placed on the water, and this weight is about like let's see 0.2 kg. Okay, and this is also the same rubber ball is placed, and this is 0.2 kg. Okay, which one will have buoyant force more? Buoyant force. What is buoyant force?
So
What?
suppose an object
experiences when it's
like sinks with its
Buoyant force. What is buoyant force, my dear? What is buoyant force?
it's an upward force.
It is the upward thrust applied by water.
Upward thrust applied by water. The
Because
force.
force in water is applied by all directions, right? So buoyant force is the upward thrust.
So when there is a density, when the density is more, whichever liquid is having more density, then it force will be more. Okay, you got me what I'm saying? It force, the buoyant force of the density high density high liquid will have more buoyant force. You got me what I'm saying? Are you able to understand?
Yes, sir.
So now if you put a water here, well, I mean this water, if you place a rubber ball, and here in glycerin, if you place a water ball, here you need more push to make this ball under the water. Here you need a little less push, because water will do less buoyant force. And here, since glycerin is very thick and its density is more, because of that density, the buoyant force will be more, and because of that, you have to give more push here to make the ball under the water. Okay, or to get the ball under the water. Are you able to understand?
Yes, sir.
Yes, sir.
Okay. So now, coming back to the next theme, let's see. Here, density, at this point, you need to write down, all of you. Okay. Which we were talking about, density of cork lesser than density of water. Okay. Understood what I'm saying? So first, we are talking about the cork. Okay. Density of cork is lesser than density of water. So what happened? Because of buoyant force, water will keep the cork
Yes.
floating. Am I right? Next point is upthrust of water. Okay. Upthrust of water on the cork is greater. Okay, greater than the weight of the cork. Weight of the cork. Therefore, cork floats. Understood now that point? Right? Yes. Give me a
yes.
second. Okay, my dears. Now the other part of it, what actually we have to understand about the nail. Is this clear with you? Density of the cork is lesser than the density of the water, and upthrust of water on the cork is greater than the weight of the cork. Therefore, cork floats. The next point is we have to understand about what we have to understand. The next one is what?
Nail.
Very good. Nail part of nail. So what happens to nail? Okay. Density of pin, that is nail, okay, is higher than density of water. Density of water. Point number 1. Point number 2 is upthrust of water. Upthrust of water. Upthrust of water on pin. What is upthrust, Prisha?
The buoyant force.
Very good, very good. Upthrust of what? Upthrust is buoyant force. Upthrust of water on pin is lesser than the weight. Lesser than the weight of the pin. Okay. Therefore,
So density
therefore,
of pin will be greater than density of water. Is that what you?
That's why the
come again, my dears. I can't follow you.
So density of pin will be greater than density of water, right?
Upthrust of water on pin is lesser than the weight of the pin. Okay. Since density is more. Density is more in the pin. Okay. Since density is more because air could not penetrate or air could not keep that upthrust. Okay. Since the buoyant force is lesser than the pin. You got me? There are no space available on the pin that where air molecules or air particles can get in so that the density of the pin become less. You got me?
Yes, sir.
Okay. Therefore, what we are, if density of object is lesser than density of liquid, okay, there are two conditions comes from this learning, this experiment. That experiment is this: if, okay, if density of object, if density of object is lesser, okay, density of liquid than density of liquid, what happens to the object, Akash? If density
The
of object lesser than
object
density of liquid, sorry,
it will float. Object will float.
wonderful. Object will float. Okay. Next point is point number 2 is if density of object is higher than the density of the liquid, then what will happen?
It will sink.
Object will sink. Object sink. Understood? If density of object is lesser than the density of the liquid, object floats. If density of object is higher than the density of the liquid, then in that case, object sink. My guys, understood? Are you able to understand?
Yes, sir.
So what is density here?
So mass by volume.
Mass by volume.
Yeah.
What is the SI unit of density?
kg per meter cube.
Kg upon meter cube. Am I right? Yes or no?
Yes, sir.
yes.
Okay. All right. Okay. The next point of this topic is, okay. The next point of this topic is Archimedes principle. What is Archimedes principle? Have you heard about Archimedes?
No, sir.
Yeah, let us understand now. What did he say? Very important that you should understand this till your senior classes. When an object, okay, when an object is wholly, wholly means what? Fully, okay, fully, wholly or partially. Partially means what? Partially means what?
Not fully.
Immersed. Okay. When an object is wholly or partially immersed in a liquid, okay, it experiences a buoyant force. Buoyant force, which is what actually? Which is equal to the weight is equal to the weight of liquid displaced by the object. Hope you all completed this. Have you written? So what is it? What did Archimedes says?
When an object is fully or partially immersed in a liquid, it experiences buoyant force, which is equal to the weight of the liquid displaced by the object.
What is mean by this?
So basically, for example, an object is immersed into, water. And then, of course, once it's immersed, there's going to be a certain displacement of the water. It's going to move a little, it's going to rise up. So over here, according to this guy, the amount of buoyant force or upward thrust experienced is the same as the weight of the amount of water displaced or moved.
Okay. So let us understand with an experiment. Am I right? All of you? Jobin? Okay. See this,
Yes,
what is
sir.
Archimedes? Yeah. See, let us understand Archimedes principle with a small example. Okay. So Archimedes principle, have you copied the concept of Archimedes?
Yes, sir.
So last line.
Yeah. So once you copied, let me know the concept of Archimedes.
So done.
Done. Okay. Now, what did he says and how do we need to understand? Suppose we have what I said. We have a bucket. Okay, we have water here in this bucket. Now, let's take a ball. Okay, and the weight of this ball is 2 kg. Okay, and I'm keeping a hole also here, and I'm keeping another bucket here, small bucket. Okay, here there is a hole. Okay, all of you with me? Suppose this weight of the ball is how much I said?
2 kg.
2 kg. And this is with full water, okay? Full water. This bucket is with full water. Okay. Now this ball of 2 kg, I'm just releasing, free fall to the bucket. Now what will happen? When the ball falls on this water, okay, this wanted to create a space. The ball wanted a space. Ball wanted a space where in the bucket. Am I right? In the bucket, it wanted a space. So what it will do? It will do that it will try to release some amount of water, okay, outside. Am I right? Yes or no?
Yes, sir.
This water we are collecting in a small balti here. Okay, a small bucket we are collecting. Now, the amount of water because of this 2 kg has come out will be equal to the amount of water displaced by the ball weight. Understood? Understood? When this 2 kg
Yes, sir.
ball, when this 2 kg ball gets into the this full bucket, okay, the amount of water get released through this hole, okay, this will also be, if you calculate the weight of this will also be 2 kg. This is what is Archimedes is telling. You got me what I'm saying? Suppose you go to a crowd, okay, Jobin. Suppose there is a crowd and you wanted to get
Yes,
into
sir.
you want to get into that crowd. What will you do?
I would try moving them out of the way.
You will move the people, right? You will move
Yes,
the
sir.
people. Am I right? You will try to move the people so that you need a space there inside.
Yes, sir.
That is what Archimedes is telling. You create a space. You're creating a space, okay, according to your body weight, according to the mass of you create a space there so that you're able to stand in that crowd. You understood now what I'm saying? Understood? Yes or no? So what will be the force here? The force will be what actually, Prisha?
So it will be the same as this displaced. So 2 kg is displaced, right?
So,
So
we can say force will be equal to
displacement of what?
the weight of the ball.
Yeah, somewhat, yeah.
Why?
It is.
Why?
Sir, because weight is the first.
What is actually F is equal to W? Why? Acceleration due to gravity.
Weight is force.
So force is equal to weight is equal to what actually what we have learned? Weight is equal to
Will be
Mass
2
into
into
gravity.
9.81 in this case.
mg. Hana?
Yes, sir.
Yes or no? So
Yes,
force
sir.
will be equal to the weight of the ball. Are you guys with me?
Yes, sir.
Yes, sir.
So what happens? The weight wanted to create a space in the water. Okay, even though there is a buoyant force, water will definitely give a buoyant force. Okay, but irrespective of that, the weight is more. Okay, since the weight is more, the buoyant force is less. Okay, since the mass is more, the buoyant force cannot upthrust the ball, and because of that, the water flows outside, and that amount of water, the flowing water which comes outside, will be equal of the space which is created inside the water, the ball. Is that clear now?
Yes,
So
sir.
now tell me Archimedes principle, all of you. Yes.
So who
And
is
I
this
saw,
question for?
sir.
Yes, tell me. Who can
Sir,
say?
are
Tell
you
me.
there, sir?
Prisha, tell me. Yeah. Okay.
Sir?
Anyone?
Sir, are you there?
Yes, I'm there.
He's replied.
I cannot hear you. Excuse me, sir.
Wait.
But we can hear you.
I can hear you now. I can hear you now.
So tell me.
So basically, sir, the original principle itself states that, when an object is immersed in water, or whatever is
Okay.
going to be the displacement of water, that's going to be the buoyant force. But after looking at this experiment, we have realized how the force over here would be weight force of the object being immersed itself. And that would also equal to the displacement, meaning that the weight of the object would also be the force of the buoyant force.
Okay. Now, application of Archimedes principle. Akash, give me some example. Quickly. Tell me some example of Archimedes of principle. Application of Archimedes principle.
Sir, can I tell?
Yes.
Sir, a ship.
Wonderful ship. What happens with the ship?
He's
Sir,
told.
they increase the
You stole.
what?
Nothing.
they increase the mass so that the weight also increases, and in turn the force, the buoyant force also increases so that it can float.
Basically, when ship comes to the water, okay. When ships comes to the water, water will, okay, water will be removed, okay, will be removed as per the, Bharat, as per the, when ship comes to the water, water will be removed as per the
Weight of the ship.
mass,
Mass.
okay, mass of the ship.
Sir, isn't
Isn't
that the
it?
weight?
Yeah, mass is
Yeah.
weight. That's what I said. Mass
Yeah,
of the
yeah.
ship. Okay.
Okay.
So what happens to the buoyant force?
It's equal to the amount of, it's equal to the weight of the ship, and it increases if the weight increases.
Okay, so buoyant force will be, okay, what will happen to the buoyant force? Okay. Buoyant force will be, okay, buoyant force given by water, okay, is equal to water displaced by the ship. Okay. Buoyant force given by water is equal to the water displaced by the ship. Understood?
Yes, sir.
Are
Yeah.
you all with me? Is it clear?
Yes,
Yes.
sir.
Okay. So now density, we have come to, from density we have come to Archimedes principle. The next part is relative density. Okay. Relative density. What I'm going to do is I have to meet a person now. I'll give you 5 minutes break, come back, and we'll continue till closing.
Okay, sir.
Okay.
Okay.
Yeah. Thank you very much. So are you guys with me? Hello. Hello.
Yes.
Yes. Okay. Sorry. I had to meet someone. So
Yes.
okay. So what did I tell you? From where we have to start?
Yeah, we just finished an example of Archimedes principle.
Okay, and we have to start with relative density. Am I right? Okay.
You never said that.
Okay. So Archimedes principle is nothing but like we have learned what is the concept of Archimedes principle, and we have taken one application also. Like we understood how a ship gets into the water and what happens to the water, and basically nothing but the space created by an object in the water because of its weight will be equal to the weight of the water displaced from, or a liquid displaced from its container, basically. Okay, that is what Archimedes is telling. Now in this, like the next area which we need to understand is basically relative relative density. Okay, so what is relative density? What can be?
Relative density. So I really don't know.
So what can be relative? So relate to one another. What does relative mean by? What is relatives? What is relatives here? Suppose either you got a relation and a relative has visited your house. What is relative density? Relation.
Yeah,
What is
related.
relation?
That's what I said. Related, connected.
Connected. Okay, connected. All it. Anything else? Akash, where is the video?
Oh, sorry, sir, I forgot.
Okay, so this is nothing but relative velocity is nothing but mass of the substance into volume of water divided by volume of substance into mass of water. What we understood, density is equal to
Mass upon mass volume.
mass by volume. Am I right? Yes or no?
Yep.
Yes. Okay. So what happens here? See, I will tell you S, L, and G. So here, what has happened? Solid, density of solid is greater than the density of liquid. Okay? Density of solid is greater than the density of liquid, and density of liquid is greater than the density of gases. Okay? This is solid, liquid, gases. Okay, so density of solid is greater than the density of liquid, and density of liquid is greater than the density of gases. All right. Now, okay, I have an experiment here. What is my experiment is, let's suppose let's see, we are making a juice at home. Okay, let's see, nimbu juice. What is that called? What is that here, my dears? Nimbu juice.
Lemonade.
Lemon. So we're making a lemon juice. So after making a juice, like what do? We pick some ice cube if you want this to be little bit chilled. So you're placing an ice cube on top of this, or you're placing an ice cube to this. Okay. So what happens to the ice cube? It floats, it sinks.
It floats.
It floats.
Ice cube is not a solid.
It is.
Then you look at this.
But it's
said
not at the room temperature.
this. No. I said solid is greater than liquid. Density of solid is greater than liquid. Density of liquid greater than gases. So ice cube is a solid. You said to me ice cube is a solid. Then why ice cube is not sinking?
It has many water particles trapped in it. And I don't know if this is correct, but it's about to melt. It's at a melting stage.
Basically, ice cube partially what happened? Partially immersed. Am I right? Partially immersed. Am I right, my dears?
Yes, sir.
Yes, sir.
Ice cube partially immersed, okay, but it is not sinking. Even though it is a solid, we consider ice cube is a solid. Okay, so ice cube is solid, but it is partially immersed in the water. And we know that solid is having higher density than liquid. Then why it is not sinking fully inside the water?
Because it's cold.
Okay, so let us understand what happens here. So we have water and we have ice cubes. Okay, we have ice cubes here. So ice cube is partially, this ice cube structure basically called kg like. Okay, the structure of ice cube is called in physics kg like. Okay, so what happens is, and we know that it is solid. Okay, so but what happens? Okay, in this structure, okay, in this structure there are space. Okay, both are made up of water. This is also H2O and this is also H2O. Am I right? Both are made up of water. Both are made up of water. But when kg like structure, when ice cube is called like a kg like structure. Okay, now there are space for air molecules. Okay, in ice cube there are space for air molecules, and because of it, its density is less. Density is less. Okay, ice cube structure is like kg like structure and it's a solid. But then what happens when that both is made up of water? Like there is a water here in the glass, also there is a water, and the ice cube is also made up of water. But when water become an ice cube, it is called kg like structure. And doing this or on the process of this structure, there is a air space. Okay, the ice cube is made up of with an air space. Okay, you understood what I'm saying? And because of the air space in the ice cube, okay, you got me what I'm saying? Density of ice cube is lesser than the water. So obviously water create a buoyant force towards
The
ice
cube.
cube, isn't it?
Yeah.
Yes or no, my dears?
Yes,
Yes,
sir.
sir.
Yes. Okay. So relating two materials density is what? Is what? Relative density. So density of an ice cube and density of water, relating two materials density. Okay, relative density. So density of substance divided by density of water equal to relative density. What is that? Density of substances divided by density of water equal to relative density. You got me what I'm saying? Hello?
Yes, sir.
Yes, sir.
Okay, now mathematically how do we prove? So distance of substance equal to mass of substances divided by volume of substances. This what is the density of substances equal to mass of substances divided by volume of substances. Understood? So here density of water equal to mass of water divided by volume of water. This is what actually relative velocity equal to mass of substances into volume of water divided by volume of substances into mass of water. So we get a mathematically we can do like this: mass of substances into volume of substances, volume of water divided by mass of water. The formula of relative velocity. Mass of substances divided by volume of substances into volume of water divided by mass of water. Understood? In the first sentence I have written relative velocity equal to mass of substances divided by volume of substances into volume of water divided by mass of water. So relative velocity.
Yeah.
This is for relative density. Relative density equal to mass of substances. This is nothing but substances. Okay. Substances, water, water. Mass of substances divided by volume of substances into volume of water divided by mass of water. Yes or no, my dears?
So,
Okay. So here, let's understand. Can I rub this? Have you written the formula of relative velocity? So relative density.
Yes, sir.
What is the formula for relative
Yes,
density?
sir.
that is mass of substance into mass of volume of water by volume of substance into mass of water.
Okay. Density of substances is equal to mass of substances divided by. In some questions, it will be like this. Remember this point. Density of substances equal to mass of substances divided by volume of substances. Density of water equal to mass of water divided by
Volume of
volume
water.
of volume of
Water.
water. Relative density equal to mass of substances divided by volume of substances into volume of water divided by mass of water. 3 questions. 1, 2, 3. Understood?
Yeah.
Yes, sir.
Okay. Now I have. Okay. A, 48. B, then I have C. Okay. Now, a ball is floating here. A ball is partially sinked here. A ball is under the water. Okay. Under the water. So here, relative density is greater than 1. Okay. Greater than 1. What is mean by that? Okay, relative density is greater than 1. Okay. Basically, if higher than 1. See, whenever we are calculating, if relative density, okay, is higher than 1. Okay, my dears, which means 1.2, 1.3 or 1.4 likewise. Okay, whenever we are calculating, if relative density is higher than 1, okay, it sink. The material sink. You understood what I'm saying? The material
Yes.
is in sink mode. Okay. Now, if relative density is lesser than 1, okay, if lesser than 1, which means what? 0.9, 0.8. Okay, the value of relative relative density. Suppose after calculation of a numerical, if relative density is more than 1, the material is in sink mode. That's what I'm trying to tell you here. The value is more than 1. My dears, when we are calculating the relative density of any product, any two product, if the value is higher than 1, then the product is in the sink mode. Okay. If the value is lesser than 1, then the product is in floating mode. Floating. So in this, what will be the approximate value here? Tell me. This is on floating. Can we take 0.9? Hello.
Yes,
Can we take
yes, sir. For
0.9?
floating, you can.
Floating. So 0.9,
Yeah.
right? Lesser than 1. Lesser than 1. And this?
What, sir?
My question is, I have given you 3 experiments. Okay. In this
Yeah.
option A, the ball is on floating. Option B, ball is partially sinked. Option C, fully sinked. So what will be the value of this approximately as per this statement? Statement 1 and statement 2.
The value of A will be lesser
Should
than
we
1.
answer? Should I answer?
Yeah.
Okay, so the second one where it's in between, it's floating, sinking. I'm assuming. So for value A, it's practically floating, right?
No, it's not floated. It is sink, almost sink.
Oh, then it should be 0.9.
It will be less.
Then,
No, it will be higher than 1.
yeah, it has
Just
to be
take
1.9.
1.2 or 1.3, 1.4, something like that. This is fully sinked. So what will happen?
The fully synced one should be like 3 or 4.
We can take 10 or 8, 9.
Yeah,
So what if is
definitely.
that it is exactly at 1?
It will be exactly at
1. What if it is exactly at 1?
so it is on floating.
Okay.
Okay. The value is greater than 1. 1 or greater than 1.
Okay.
Okay. Right. So, for example, if the ball, see now if you have an image like this and this and this, which means it can be taken as anything 0.9, 0.8 or 0.7 or something like that. Or this can be taken it as 1.2 because partially synced, so 1.3 or something like that. Or you can take it like it's fully synced, it can be 9 or 10. What it says, relative density after calculation, after numericals, after calculating relative density of an object, of two objects, if the value comes greater than 1, okay, then the material is in sink mode. Okay, lesser than 1 means it is on a floating mode. Understood what I'm saying?
Yes, sir.
Okay. No. What is the SI unit of relative velocity? So relative density, I'm coming relative velocity.
So it doesn't
What is
have
the SI unit?
Right, because everything will get cancelled. Kilogram meter cube will get cancelled.
So in both the cases, we are discussing relative density only, right? Whether it is on a numerator or denominator, we are discussing only density. So both are densities. So kg meter cube divided by again kg meter cube. Am I right? Yes or no, my dears? So both will get cancelled. So no SI unit for relative density.
There is no SI unit.
No SI unit.
So how
Why?
everything gets
Numerator is also density. Denominator is also density. Come back to the previous one. Now, what I have told you. What did I say? What did I say?
SI unit is kg meter cube.
Density of water equal to mass of water divided by volume of water. Am I right? Mass
How
of
do we
water.
write
So mass of water is also we know that kg of. Am I right? Kg, right? Volume of water is also we are taking kg. Am I right? So what will happen?
Nothing.
Both is kg meter cube. So kg meter cube, both will get cancelled. So this will be 0. Automatically there is no SI unit.
How will we write this? How will we represent this?
Akash, numerator is what actually here?
Yeah, I get it. I get it. It's 0. It's nothing.
0. Okay. So relative density has no SI unit. No SI unit.
Okay, sir.
Understood? Remember this. Relative density is not having SI unit. Am I clear?
Yep.
Okay. So what is relative density? Give me a definition. Relative density equal to
A density of the substance upon density of water.
mass of the substances
Oh,
divided
sorry, mass. Yes, sir.
mass of the substances divided by volume of substances into volume of water divided by mass of water. Is it clear to you?
Yeah.
See, density, we know that actually whenever a material is having no space, okay, suppose, okay, this is the material and no space anywhere, okay. So the density of this particular material is higher, okay. And if there is a same material and there is a space, okay, what is made up of it? It is made up of its small particles or materials. This material is made up of its own small particles or small materials. Or those small materials are having space in between, air will definitely occupy. When there is a space for air, okay, obviously density will become less. Suppose a ship is there, a ship is on water, and we are putting a small nail on water. Okay, the nail sinks and ship is not sinking. The same way, the nail, if you pick it up and keep it on the ship, what will happen? The nail never sinks. Am I right? Because the ship is made up of in a condition where it can occupy large volume of air. Am I right? Large volume of air gets passed inside and releases. Am I right? Yes or no? So that ship cannot sink.
Yes, sir.
So here what happens, like, so density is density to relative density. So relative density is relating to materials density. Both the materials SI unit is kg. Am I right? Density is same na in both the condition. So density of a water, density of an object. Relating to materials density, water and the object.
Yes, sir.
Got me?
Yes, sir.
Okay. So I'm coming with a small numericals based on the relative density. The question is, let's understand the question. Question is, all of you write with me, relative density of silver is 10.8. The density of water is 10 to the power 3 kg meter cube. What is the density? What is the density of silver SI unit? So the question is, relative density of silver is 10.8. The density of water is 10 to the power Q or 10 cube kg meter cube. what is the density of silver SI unit? So what do we do?
So you just cross multiply.
Tell me. Tell me. What is given in the data? How do we
You're
do?
given the relative density of silver and you're given the density of water.
Relative density of silver is how much? It is how much?
10.8.
10.8. Next, relative density formula. Relative density formula.
Density of substance by density of water equal to the relative.
Okay. So here density of silver divided by density of water. Am I right?
Yes,
Am I
sir.
right? Yes or no?
Yes, sir.
So how do we do? Density of substance divided by density of water equal to relative density. I have already told you the this thing. So here what we get?
It would be 10.8 into 10 to the power of 3, which would be 10800.
Here we are doing relative density equal to density of silver divided by density of water, which is nothing but density of silver equal to density of silver equal to relative density of silver into density of water. Density of water. So how do we get it? Density of silver 10.8 equal to relative density of silver, which we don't know. So what do we do? We can write density of silver divided by density of water. Okay. So we can write like this: 10.8 equal to x divided by density of water is already given there, right? How much it is? How much it is? In the question. I can't hear you, Prisha.
10 raised to the power 3.
10 raised to the power 3 equal to x. Am I right? So if you take this to LHS, then what we get? 10.8 into 10 to the power kg meter cube. So the equal to x. So x is equal to 10.8 into 10 to the power 3 kg meter cube, which means the resultant will be more than 1. Okay, which means what happens? The silver sink. Silver is in the sink mode.
Yeah.
Correct, na? So any doubt? What we have done? What is the question? All of you read the question. I think you have a confusion now. Read the question.
Can I?
Yeah.
Okay, I'll read the question. So the relative density of silver is 10.8. The density of water is 10 raised to the power 3 kg m3. What is the density of silver?
Silver SI unit. Okay. So SI unit is just to confuse you. There is no what SI unit will
Yeah,
get.
obviously, we'll get the SI unit anyway.
Okay. So now here, what we know, relative density of silver is given to us 10.8. then what is that? Density of water is also given to us. So relative density equal to density of silver divided by density of water. Am I right? Yes or no, my dears? Okay.
Yes.
So density of silver equal to relative density of silver into density of water, which we have already seen in the last equation. Am I right?
Yes.
Yeah. So density of water equal to mass of water divided by volume of water, or density of substances equal to mass of substances divided by volume of substances. Relative density formula is density of substances divided by density of water. Relative density equal to density of substances divided by density of water. So relative density is equal to relative density of silver divided by water. So relative density of silver into density of water, which we have done here. So that is what equal to X. Understood? So the volume of the answer which we get is more than 1. Okay. So automatically it is in the silver is in the sink mode. Am I right?
Yep. Yep.
Okay. Any doubts? Bharat,
No doubt, sir.
take that formula and put that values. That's all.
Yeah, you just replace it.
I have given you 3 formulas. What are the 3 formulas? Tell me. In relative density, the first formula is
Density of substance by density
divided
of
by density of water equal to relative density. Now density of substances equal to
mass of substance by volume of substance.
volume of substances. Density of water equal to,
Oh, yeah.
Mass of water by volume of.
so mass of substances divided by volume of substances into volume of substance, volume of water divided by mass of water. Okay. Okay. So now with this gravitation chapter ends. Okay. The gravitation chapter is getting end here with the density. So we'll quickly recall density once again. What is density?
Mass
It
upon
is
volume.
Density is what actually?
mass upon volume.
Okay. What is the SI unit of mass? I'm asking our Jobin. What is the SI unit of mass? Jobin? Jobin Joseph. What is the SI?
Sorry, sir.
What is the SI unit of mass? SI unit of mass kg. Volume? SI unit of volume?
Meter cube.
Okay. So what is density? How do we define density?
We define like the meaning of density.
Tell me, Prisha.
So this is what I copied. Given volume, whatever mass.
How much mass exists in given volume? How much mass exists in given volume? Density we can define is like how much mass exists in given volume. Density equal to how much mass exists in given volume. Okay. You remember my thick forest and thin forest. Same area, how much mass, how much amount of mass is existed in a given area. Got me, my dears? Okay, now take glycerin, water and all. Okay, so in glycerin, obviously, it is thick liquid. Automatically, the buoyant force will be more. Okay, so thick. Okay, in thick liquid, the buoyant force will be more. Then next, that's why the cork and nail experiment. I said cork and nail. Why cork is not sinking? While nail is not, floating. Okay, next. So upthrust of water on the cork is greater than the weight of the cork. Those and all you should study. If density of object is lesser than the density of liquid, what will happen to the object? Density of object is lesser than the density of liquid.
It will float. It will float.
Okay. If density of object is higher than the density of the liquid,
then it will sink.
Okay. What is Archimedes' principle?
Can I?
Yes.
When an object is fully or partially immersed in a liquid, it experiences buoyant force, which is equal to the weight of the liquid displayed by the object, plus the weight of the outside body of the object being immersed.
Now, Jobin Joseph, tell me very simple. What is the now? They have told me the definition of Archimedes. Now, Jobin should tell me exactly with an experiment what happens. Jobin, Archimedes principle.
Pardon?
Archimedes principle. Give me an example.
Yes, sir.
Hmm.
Just flip pages once.
Give me an example, quick.
Sir, the cruise ship.
Bharat, tell me what actually, how do we claim Archimedes principle with an example?
So a ship like we increase the mass, like because the buoyant force varies with the mass of the ship, we increase the mass to
No.
increase the-
See, now I've told you an experiment that you are taking a full bucket or full pots of water, okay, fully filled, and if you keep a 2 kg ball onto the water, okay, when the 2 kg ball is touching the surface of the water, it tries to create a space, okay, which the ball wants to create a space of 2 kg. Am I right? To in the water. So what happened? The 2 kg amount of water, it disperses out. Okay, that amount of water is getting outside from that bottle or that bucket will be equal to the weight of the ball. You got me? Will be equal to the weight of the ball. Could be any material. If it is 5 kg ball, then the 5 kg water will flow out. If it is 10 kg ball, then the 10 kg water will float outside or will flow outside. Am I right? Yes or no? That's what Archimedes is telling. And I've told Jobin that if you're getting into a crowd, for you to create a space there, you remove people from there so that you can get inside. Understood? Is that clear?
Yes.
Okay. Now, if relative density is more than 1, what happens to the material?
More than 1, it sinks.
Lesser than 1?
It floats.
It floats. Okay. So SI unit of relative density is what, Jobin? Relative density SI unit.
Yes, sir. kg/meter cube.
No, I'll kill you actually. What is the SI unit of relative density?
I don't
Akash?
write. I can write it on a paper. Who was right?
Akash,
It
relative
was
density. What
kg
is
slash meter cube.
Akash?
It is just nothing. There is no SI unit for related to
There is no SI unit because both are kg meter cube. Numerator and denominator both are kg meter cube. So there is no SI unit for relative density. Is that clear now, my dears? Okay. So we are completing the which topic? Gravity.
Density.
gravity.
Gravity is over here. We are moving to the next topics is okay. The next topic is sound. We're starting with sound. So very interesting chapter, very interesting and very if you concentrate little bit, there are so many things to learn. It's very interesting, very interesting. I'm interested in these topics because it is easy to teach and it is easy to understand. Okay, so there are few questions. One of my favorite topics, sound. So there is and you already know about these topics. Okay, why I'm telling that, even you have studied or not studied, you know something about sound. You got me what I'm saying? So few things which we will be discussing here is, okay, what is sound? Next is production of sound. Production of sound. You can write down all these points if you want. Propagation of sound. characteristics of sound. Characteristics of sound waves. Okay. Which means here we have frequency, then we have B as amplitude, then we have C speed. Next is reflection of sound. Reflection of sound. Under this we have echo, 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 and we have reverberation. Then we have uses of multiple reflection of sound. Multiple reflection of sound. So these are all the points which we are going to discuss in this chapter. My dears, are you able to understand?
Yes, sir.
So what are all we are going to discuss here? What is sound? Production of sound?
Production of sound.
Yes, tell me.
Oh, no, I was just reading out the same thing. So what is sound? Production of sound,
Yes, read,
characteristics of sound,
read.
propagation of sound.
Oh.
So what is sound? Production of sound, propagation of sound, characteristics of sound waves, which talk about frequency, amplitude, speed, and reflection of sound, which also talks about echo and reverberation and causes of multiple reflections of sound.
Yeah. So what we understand sound? My dears, what is sound? So let's discuss on this first point.
So is it a form of energy that like gives us the sensation of hearing in our ears?
Okay. Anything else? What is sound?
We've never done
Is
this.
sound only, can we touch sound? Can we touch?
But we won't feel it.
Is it that only sound you can hear only? Is that you can hear, not to
No.
touch? Can you touch sound?
Vibrations, we can touch vibrations, we can feel it.
Okay. So sound only to hear, no touch.
Sound you can hear, and sometimes you can feel the vibrations when they're like really loud. But yeah.
Okay. So is sound an energy?
It is an energy, yeah.
Should
Is it an energy?
Yes.
Okay. So what was the next point with us actually? Production of sound, am I right? Production of sound, right? I told sound, okay, we'll be discussing each point very detailedly, but I'm just giving you an outline here. So sound is only to hear and not to touch. Sound is a form of energy. So what is sound? Sound is a form of energy, sound only to hear and not to touch. All right? What is sound? Sound is only to hear and not to touch, and sound is a form of energy. Now, production of sound, from where the sound comes?
no idea, sir.
So states of matter like
From where it
like
comes?
a medium, like whatever surrounds us, like air, it acts as a medium for sound to travel, to vibrate. The particles vibrate and gives us sound.
Okay. Okay. Now, you would have done this rubber band experiment. Okay. Suppose you keep rubber bands in two fingers, like you keep in between these fingers, and you just try to check the elasticity. Okay, pulling one side of the rubber band and release slowly, and keep the rubber band very close to your ears. What happens? What you could hear?
Sound.
Sound like a snapping sound.
What kind of a
Vibration.
sound?
Vibration.
A snapping sound.
Akash, correct. Vibration. Okay. So what happened? Okay. Production is equal to vibration. So sound comes from where? Sound comes from vibration of any material. Sound comes from where? From the vibrations of
Vibration.
any material. From the vibration. So production of sound is equal to vibration. Okay, my dears. Production of sound. Okay, see, when you are doing this rubber band, you are keeping rubber band between the fingers and you're just trying to pull it one side and release it slowly. What happens to the rubber band? Rubber band starts vibrating. Then vibrating, it comes with kind of a sound. What kind of a sound will come? Give me an example. What will be that sound? Kind of a B sound.
Yeah.
Small b.
Yeah.
Kind of a correct now. Kind of a how do you? I mean,
Guitar
have you ever
string.
experienced a B sound? A sound of a B.
Yep.
So such kind of sound comes from where? From that vibrating rubber band. So when vibration happens, sound produces. Simple. When vibration happens, sound produces. Speaker, have you ever checked an open speaker? What
Yeah,
happens
it's
to a
like-
speaker?
yeah,
Speaker
it's
starts
vib-
vibrating in the car and all. You see that, when you increase the volume, what happens? Speaker vibrates.
Yeah.
Speaker vibrates. If the vibration stops, sound won't come out.
Yep.
So production of sound equal to sound comes from
Vibration.
wonderful. Sound comes from vibration. Is that clear, my dears?
Yep. Yes, sir.
Okay. Now propagation of sound. Next point is what? Next point is what? What is the
Next
next point?
is characteristics of sound.
No, propagation is the production of sound, propagation of sound. Am I right?
So is
Propagation.
it
Longitudinal waves and transverse waves.
What is propagation mean by? How sound travels. Is sound need a bus or car to travel? Okay.
No, sir.
Propagation of sound means how sound travels. Okay. How sound travels, which is nothing but waves. The modem of sound or the method of sound. So graphically, sound is represented in this method. Okay. The sound waves are represented like this graphically.
Yeah.
Okay. You understood mean by?
Yes.
Why
yes.
it is?
Yes, sir.
Now, vibration I said, okay, look at my dears, goes up, come down, goes up, come
Because
down,
it's like
goes
vibrating
up,
frequency.
come down. Yeah, vibration. Am I right? Yes or no?
Yeah.
So sound travels in this way. Now, why did we choose this kind of model? Because it goes up, it comes down, goes up, it comes down, goes up, it comes down. So we cannot do sound travels like this. Graphically, we cannot represent the travels of sound like this.
Yeah.
You got me?
Yes, sir.
Yeah. So reflex, next point is what actually? Characteristics of sound, okay? And in that frequency is there, amplitude is there, etc. is there. All right, okay. So what I'm trying to tell you is sound need a frequency to travel. Sound is limited to a particular area. Suppose I'm talking from here, you are telling me, sir, I cannot hear you, or I cannot hear you, I am also telling. Which means what happened? It has got a particular area to cover. Okay, that will reach to a particular frequency. Beyond that, it will not reach. Suppose, okay, there is a crowd of 1,000 people, and I am standing on a stage to speak to this 1,000 people. Okay, can I speak with my plain mouth or free mouth to the entire audience?
If they are
Where I
really
need a
close to
person,
you,
where
Yeah,
I
you
need
need
a
to.
what material I need?
mic,
Mike, what did Mike do?
it takes the vibrations
It
and
attaches the
Mike increased
vibrations
the
and amplifies
frequency of
it.
my speech.
Yeah.
Through which material?
uh,
Through
what
an amplifier.
oh yeah,
You have seen the amplifier, right? Yes or no, my dears?
Yes, sir.
Yeah.
There will be an up guy sitting and operating the amplifier. Am I right?
Yes, sir.
So I speak through the mic. It goes to the amplifier. Amplifier increases the volume of my frequency and the speed increases.
Speed.
Yes, the volume, the sound travels fast through amplifier.
So the volume is basically the speed of sound increased so that it will be louder.
Yes. Understood now? Okay. Next point is reflection of sound. Light reflects, yes or no?
Yeah, it does. It echoes.
Sound is also reflects. How? Give me an
After
example.
it hits the surface, it
So
hits
like
back with.
ultrasonic sounds, like a bat uses ultrasonic.
No, very simple, very simple. Sound reflects. Have you ever experienced echo sounds?
Yes.
So I just
Echoes. Which means what? Sound reflects. Sound reflects. Am I right? The echo point. Okay, next.
Yes, sir.
Reverberation is what actually? Next point is reverberation. Echo, I've told you. Reverberation. Reverberation. You know what is the point when I told you? Akash,
Yes, sir.
where were you when I've given you some points, the gist of these topics?
Yeah, I was. Yep. Oh, yeah.
What is reverberation? Reverberation.
I don't know.
Any idea?
Not
I would say some sounds, okay, some sounds large and long. Sound persists.
yes.
Sound persists. What is the meaning of sound persist? Suppose
It
if you would
continues
have,
to
yes.
it continues to exist.
Suppose you break a small balloon, what happens to that?
You hear small blasting sound.
No, one small balloon, if you're breaking, if you break a small balloon, what happens? The balloon, say, one small sound it makes and it goes out. Suppose several balloons are together bursted. What happened to that sound?
The same thing, but larger.
Yeah.
Larger, and it persists on the air for some time. Am I right? After being the complete breaks, still sounds is there. Have you ever observed after festivals when there are cracks,
Oh, yeah.
padaks, big padakas, big crackers when they
A
are
bomb.
bursting, large volume of crackers when they are bursting it, what happens? Even after the bursting, there is some amount of time. For some amount of time, sound is persisting on the air. Am I right?
Yes, sir.
Yes or no, my dears? So that is nothing but reverberation. Sound persist. Reverberation equal to sound persist. If anybody asks you what is reverberation, reverberation equal to sound persist. Sound persist. Understood now?
Yes, sir.
Is that clear?
Yes, sir.
Okay. Now reverberation is clear. Now, next point of this topic is few points which we are going to discuss in the next class only. But now I'll just give you a gist of that and then we'll close the class. Okay. The next point which we are going to discuss in the next class in detail is, okay, intro of this is application of ultrasound, structure of human ear, then NCRT or numericals, basically. NCRT level numericals. Okay? You understood what I'm saying? Application of ultrasound, structure of human ear, and numericals. All right? We need a minimum 3 or 4 classes to complete sound. You got me? So, tell me what and all you understood about sound in today's class as an introduction.
Reverberation, reflection.
Sound
firstly,
reflex.
firstly,
Sound
how
reflex.
sound is produced. Yeah,
Okay.
sound reflex. Then the initial first thing we had learned was how sound is produced, which is basically vibration of any molecules. And then we learned about, whether sound reflects or not. How does it reflect, echoing, reverberation,
How sound waves are traveled.
propagation too.
Graph of sound waves. Okay. Graph of sound waves. Okay.
Yes, sir.
Okay. I'll give you one definition of sound. With that, let's understand what happens. Sound is a form of energy. All of you write with me. Sound is a form of energy. The sensations felt by our ears is called sound. The sensations felt by our ear is called sound. What is sound? Sound is a form of energy.
Energy.
Sound is a form of energy. The sensation felt by our ear. Can you tell me the most difficult sensation that you experienced in a day? Sound sensation.
What,
How?
sir? Could you repeat?
The most difficult or the most disturbed sound sensation you have experienced in a day.
Sir, today our principal started speaking. She started giving a speech.
Other than that,
So we had a parade today, so probably the drums.
no.
Sir, the
I would say something else is there.
Sir,
You
the
got
chalk-
some sensation. Sorry?
the chalk like scratching against the board.
Yeah, the morning alarm. Am I right? The first
We don't have
sensation.
we don't have alarms. We have
You don't
something
have
worse.
alarm.
Sir, we have
So if there is a wake up alarm, if there's a
We
wake
don't
up
have
alarm,
alarms.
no,
Sir,
no,
we have
even if
something worse. A lady just comes up to our door and screams.
knock it.
No, no. Knocking is fine. She screams.
So that is also sound sensation. The sensation which you experience in the morning. If you have an alarm or if you have a knocking, somebody is knocking on your door or somebody screams at you, screaming at you in the morning. So the most sensation, the sensation felt by our ear is called sound. You got me, my dears?
Yes, sir.
Yes or no? So non-living thing
Yes.
is also having sound, living thing is also having sound.
Doubt with Akash, sir. I'll just go. Can I go?
Wait. I'm closing it now. Non-living things and living things both are having sound. Anna? Yes or no?
Yes, sir.
Okay.
Yes, sir.
So understand the basics of sound and sit in my next class. Learn gravity completely from the beginning till the last. Okay. The next test also will be conducted based on gravity only. Okay. So which will have density and relative density questions.
Okay, sir.
And sound, rework on sound and then come and sit in the next class, next physics class. Till then, all the best. Take care. Take care of
Thank you,
your
sir.
health. Yeah.
Thank you, sir. Bye, sir. Good night, sir.
Bye. Good night.
Thank you, sir. Bye, sir.
Thank
Good
you,
night,
Nisha.
sir.
Thank you.